friends, I welcome you all to my another technical video. My name is James Kuti Thomas, retired electrical inspector from Kerala. Today the topic of the video is related with the communication lines drawn through the transmission towers of the utilities. We all know the cable TV lines drawn through the electric poles of the distribution companies. Today we are discussing about the fiber communication or the advanced communication through the transmission towers. Okay, let us move to the topic. Now you can see with the screen antenna. We were using such antenna for getting TV channel. We were actually getting only one channel that time. But after that, cable TV came. Cable television or CATV. It was cable TV lines were drawn through the electric poles, such poles. You can see the cable drawn here. So through this cable, we were getting so many channels. For this cable line, we were using either coaxial cable or optical fiber cable. For cable TV communication, we were using a radio frequency cable or RF cable, or we call it as coaxial cable. There will be a single conductor through the cable. But the problem is RF cable will be affected by electromagnetic interference or lightning. We are using this RF cable or the coaxial cable through the electric poles. So of course it will be affected by electromagnetic interference, and that's a disadvantage here. Now we were moving to optical fibers. Optical fiber means, what is optical fiber? Fiber means it is made of glass or plastic. So you may know about total internal reflection. When light fall upon a surface at a particular angle, depending upon the refractive indexes, it will be totally reflected through the glass, or it will be passed through the glass tube itself. That is what is called total internal reflection. Based upon this total internal reflection, optical fiber communication was developed. You can see laser signal here and received in the other end. So to get you an idea, I have shown 2-3 pictures here. I am not discussing more about the cable TV lines which are drawn through the electric poles of the distribution companies. In Kerala, actually, we need permission, electrical safety permission from electrical inspector for drawing such cables through distribution poles. But we are stopping that topic here. Now we are entering to the actual topic of this video. We are discussing about the communication lines through the transmission towers. You can see on ground wire at the top of the tower. There will be either one conductor or two conductors will be there. The purpose of such a ground wire or earth wire is for lightning protection. And it is called as catenary wire, or it is a horizontal air terminal, or we can call it as a shield for protecting the other phase conductors, or we can say it as an earth wire. So actually the purpose of the topmost conductor is for lightning protection only. But we are converting the purpose of this ground wire to communication lines that we can discuss. Actually, we should understand the purpose or the need of communication from substation to substation, or a load dispatching center to another central grid or something like that. We need communication or the transfer of data or speech in between the utility centers. That's a need of data transfer. See, for years back, we were using carrier communication. See here, carrier communication. You can see on a barrel-like piece in transmission towers or the substations. You can see such a barrel. What is actually, it is called as wave trap or line trap. Through the single line, through the transmission line itself, the supply power of 50 Hertz and the communication signal of kilohertz range will be passed through the single line or the transmission tower or the transmission wire itself. We will be sending both of the signals. Actually, these signals will be separated by this wave trap. So such a communication was there. Even now it is in practice. So it is called as carrier communication. The transfer of data or speech being very needy for the utility controls. They were using, in addition to such a carrier communication, the telecom lines, or they were using this wireless microwave communication. And in addition, they were doing some experiments by drawing fibers through the transmission lines. See here on OPGW, optical ground wire, means they replaced the topmost ground conductor with a special type of conductor in which there will be fibers drawn through the center, and in the covering the metal part will be there. So the outermost area or the metal part will be for the lightning protection, and the inner fiber will be used for fiber communication. So such a conversion was, or they were doing such experiments that time, and that is what is called the OPGW, optical ground wire. I will show another picture. And in addition, see here it was discussed about the ground wire. But in some cases there will not be any ground wire. In such cases they were converting even the phase conductor itself through just this OPGW like conductor. Means a phase conductor will be changed to the inner fiber plus the external metal part. So it is what is called the OPPC, optical phase conductor. Okay. And another one is OPAC. OPAC means optical power attached cable. Optical power attached cable means fiber will be attached or tied along with the ground conductor or the phase conductor. That is what is called OPAC. So there are three types of attempts they have done. One is OPGW, then OPPC, optical phase conductor communication or cable, and then OPAC, optical power attached cable. Okay. Actually, these OPGW or OPPC or OPAC were already developed even in 1980s in all over the world. You can see the first patent of OPGW and OPPC was actually given in 1977, and already even in 1980 it was developed or implemented in all our world. See here, for such a fibers there is an Indian standard or international standard 60794. You can download this IEC international standard free of cost from internet for personal purpose. So many data there regarding these fibers, specification and experimental results are there. Those interested can download this standard. See, as per this standard, for such communication, for the communication through the transmission lines, the fibers must be single mode fibers. See, actually what is single mode fibers? See here, you can see a fiber cross section. The central portion is called core and the surrounding portion is called cladding. See here, through the this fiber on light signal is or optical signal is passed. If it is single mode, you can transfer only a single light signal or the single wavelength signal. But if it is multi-mode, you can send many light signals. But the problem is, if it is single mode, you can send it for a long distance with a large bandwidth. That is the advantage of single mode. That is why in the standard they recommend for single mode fibers. In the multi-mode section, you can see many signals or many signals with different wavelengths are passing through the multi-mode, but it can be used only for the short distances. In the suppose in the cable TV and or the consumer end, you can use such multi-mode fibers. So in short, for such a communication, only the single mode fibers is recommended. See, another thing, the joining of the fibers, it is called, technically it is called as splicing. See, we know it is done in the neighborhood of transmission towers. So it must be carefully handled. Splicing should be carefully handled. I told you, actually the purpose of this communication is for their internal communication or the transfer of data and speech for the electric controls. But since there is a large scope of data transfer, they can lease out some fibers or the channels for other companies, and thereby they can gather more revenue. Such utility companies can gather more revenue. In this screen you can see some dropout point in East Towers, and you can see on a black box here, it is called splice enclosure. So such splicing points will be there in substation or in some tower locations. See, here I have explained about the advantages and disadvantages of such fiber communication. Actually, I am not going deep into such section. Basically, we can say it will not affect this electromagnetic interference will not be affected through such a fiber communication, but it is much expensive, you know. See, here in the screen you can see the regulation begins such communication which we are discussing now. See, I told you about the carrier communication. In this role, this actually it is from the construction standard of Central City Authority Regulation 2010. As per this regulation, in addition to this carrier communication, you can move to OPGW or some other technology, similar technology. See, so this type of or OPGW or fiber communication is as per Central Electricity Authority regulation only. See, here in the right side you can see on OPGW. See, here OPGW is having the metal cover which is used for the lightning protection, and inside this metal part there will be one tube which is made of metallic or plastic, and in the tube there will be fibers. So these fibers are used for communication. Apart from this OPGW, we have discussed about OPPC, optical phase conductor, and optical power attached cable. You can see here OPGW in the top of the tower and OPPC, and then OPAC also in the figures shown. See, other than these three, OPGW, OPPC and OPAC, there is another category of fibers which is called all dielectric self-supporting and metallic aerial self-supporting. Means in the name itself you can see that it is self-supporting. So no additional support is required for this ADSS or MASS. I shall show you the pictures also. Actually, you can see the difference in their names, ADSS and MASS. ADSS means it is all dielectric, and the other section it is metallic. So means in the covering will be in dielectric in one case, and in the other case it will be metallic. You can see here the position of the ADSS or MASS. It is drawn below the phase conductors. We will discuss about that in detail. Now we shall move through these 5 types of cables one by one. Just I am giving only an introduction only. But I have added more text here. You can please read and go through. I will be taking only the important points. Here OPGW, I told you it is having 2 purposes, one for the lightning protection and for the other parties transmitting data. Here you can see on picture of this OPGW, you can see very clearly the fibers, and around that there will be a pipe, and around that the metallic part. Metallic part is used for this lightning protection. See here the cross section also. Just to go through the pictures. Now optical phase conductor, OPPC. Here also I told you, just like OPGW, phase conductor is replaced with OPPC, means fiber will be there inside. Then OPLC also, just go through the text. Okay. Now you can see ADSS cables, and please note the location of the ADSS in the transmission tower. It is below the phase conductors. Then the clamping also shown here. Just read that. Now the picture here is ADSS cable, and the fibers shown on cross section is also shown here. See, actually ADSS is having some disadvantages. See here, its life will be going down through some reasons explained below. But I am explaining only about corona effect and dry band arcing. See here in the picture, you can see on phase conductor, and below that on fiber conductor. See, what's the problem? Fiber, this fiber is connected with the poles with some mechanical supports. The mechanical supports may have some sharp edges. So this sharp edge is in the vicinity of the electromagnetic field, and due to this sharp edge and the air or the ionized air around this point can cause corona effect. So corona effect means it is an arcing. So by this arcing, the fiber, the accumulated fiber may get damaged. Next one is dry band arcing. We know actually the fiber is non-conductive, but what will happen? Contamination may accumulate upon the fiber, and the pollution can happen to convert this fiber itself to some semiconductive type. So below that phase conductor, this semiconductor surface will create some capacitive effect. That capacitive effect will cause some current to flow through the fiber, and the fiber may get warm, and it can create, or it can make some dry points, means due to the heat some dry, or the fiber sheath can be converted to some dry bands. So dry band means across that dry band there can be some potential difference which will cause further arcing, and finally this fiber may get damaged. That is what is called dry band arcing. So for this corona effect and dry band and such disadvantages, there must be regular checking of these fibers by the experts. The next one is MASS, metallic aerial self-supporting. I told you the difference is it is having the outer cover with metallic material. So actually both of these ADSS and MASS are having somewhat similar purpose, but there will be some difference in the construction, and depending upon the construction the purpose also will be different. Okay. So far we were discussing about the aerial method, or through the air, the drawing of the cables were discussed here. Now in some cases there may not be possible for such aerial drawing, and in such cases underground cables will be drawn. I told you the purpose of this communication is for the utility. So if it is not possible through the aerial tower or through the towers, they will move to underground cables, and in the right of way area itself such fibers will be drawn, and these fibers may have some armoring, or there will be some locator wires, means it is underground, so it may have some locator wires. We know about the fault current. Due to some fault, the fault current will be passing through the ground. That may affect these fibers. That part should be cared for maintaining this underground cable. So far we were discussing about the different possibilities of communication through transmission towers, and I told you regarding this OPGW, then OPAC and OPPC. See, OPAC means just tying a fiber along with the conductor. Then I told you regarding this ADSS and MASS. And another point I told you regarding this standard, as per the standard, this fiber must be single mode type. See, suppose you are having an OPGW, it is having a bandwidth, you can add some external fiber along with this OPGW, just like OPSC, you can tie it with this OPGW, and thereby we can increase the bandwidth also. Then about ADSS, I told you regarding a disadvantage that it will be affected by corona effect and dry band arcing. See, then regarding the electrical safety, these towers, along with the construction itself, such fibers or such communication lines will be done, and the inspection will be done through the electrical inspector, and the permission will be given. Once the permission is given, these towers are coming under the control of these utility companies, and after that suppose some splicing point or some agreement in between a cable operator and the utility, those things will be controlled through the utility company only. Here you must note one thing, that it is not a wireless communication. We are transferring a huge data through these transmission towers. We can utilize it for some applications. Suppose we are having a hospital on location and they are having a sister concern in another area, they can communicate or they can transfer such a huge data through the transmission towers. Another purpose is, suppose you are having an interior area, interior village, we need to give the people such internet for which we can utilize these towers, because we can provide some splicing point there, and there will be some agreement between the cable operator and the utility company, and depending upon their agreement they can provide some dropout point or a splicing point there. And actually this type of communication is having much scope. I don't know how far we reached in India, and but in the other countries these towers are utilized very much. And another thing, even in education base also, this power transmission line communication is having much scope for. I request to the young generation, you can do after this electrical BTech, you can move to such a fiber communication field and get into such a power transmission line communication. Okay, please share this information with others if you are finding it very useful. Please subscribe to my YouTube channel, and we can see through another video, and thank you for your patient listening. Thank you.